Welcome to the deep dive. We sift through the science so you get the real story. And today it's sleep. If you're online at all, you know it's just everywhere. Sleep advice, I mean.
Oh, yeah. Weighted blankets, supplements, endless TikTok hacks.
Exactly. It's this huge, like $100 billion industry.
Yeah.
Completely overwhelming.
And honestly, a lot of it is just noise. It distracts from what's scientifically really fundamental. The core issue isn't a lack of stuff to buy.
Right.
It's that our modern lives are constantly messing with our biology, our internal clocks, the circadian system. That system runs everything, the hormones, digestion, the lot.
So that's our mission today then. Cut through that noise, find the actual science-backed levers that really reset that internal clock.
Precisely. We need to find what truly synchronizes us.
We're talking essentials, the proven basics. And we've got some, frankly, surprising new data, too, on things like university schedules, even napping.
It all comes down to alignment. When your internal clock is out of sync with the outside world and your behavior, you get what scientists call circadian misalignment.
And that's bad news.
Yeah, it's linked to fuzzy thinking, mood problems, and serious long-term risks, too. Heart disease, depression, the list goes on. So the research points to three key pillars for getting back in sync.
Okay, let's lay them out. The three fundamentals. Sounds simple, but I bet the execution is tricky.
It can be. Okay, number one, getting strong contrast between light and darks.
Light and dark contrast. Got it.
Number two, consolidating your meal times, basically when you eat.
Meal timing, okay.
And number three, consistency, keeping your sleep schedule really stable. That's the anchor.
All right, let's dig into that first one. Light. You called it the primary synchronizer.
Absolutely. It's the most powerful signal your brain uses to set its master clock. Think about it. We evolved outdoors under bright daylight, packed with blue wavelengths.
But now we live inside most of the time.
Exactly. So we're basically starving our brains of that crucial signal. It's a fundamental mismatch.
Can you give us a sense of scale? Like how dim is indoors compared to what our bodies expect?
The difference is honestly staggering.
Yeah.
Your typical home or office, maybe 100, 250 lux on a good day.
Okay.
Step outside, even if it's overcast. That blue-rich daylight is like orders of magnitude brighter. We're talking 10,000 lux or more.
Wow. Okay.
So the key insight here is maximizing that contrast.
Yeah.
Bright light during the day, real darkness at night.
So chasing bright light in the day isn't just about feeling more awake.
It's much more profound than that. Getting enough bright light, especially earlier in the day, actually primes your system for a strong melatonin release at night. Melatonin is your sleep hormone.
Okay.
And interestingly, it seems to make your system a bit more resilient. It sort of buffers you against the negative effects of small amounts of light later on.
Like a protective effect.
Kinda, yeah.
Yeah.
If you get good daytime light, you might handle a tiny bit of light pollution at night slightly better than if you spent all day in dim conditions.
Okay, but what about that light pollution? Artificial light at night, or ALAN as the studies call it. How bad is it really?
It's incredibly disruptive, especially around the middle of your natural sleep period. That's when your system is most sensitive.
Even dim light, like a phone screen or a light from the hallway.
Yes. Even dim light can measurably suppress melatonin and increase your heart rate overnight. It's basically telling your body, hey, maybe it's not nighttime after all.
And the sources linked this to some pretty serious mental health outcomes.
They did. That huge UK biobank study, almost 90,000 people. It was quite stark.
What did they find?
They found a clear link. More light exposure at night was associated with a higher risk for a whole range of psychiatric issues. Major depression, PTSD, psychosis, bipolar disorder.
Wow.
But crucially, the opposite was also true. More daytime light exposure was linked to a lower risk for many of those same conditions.
So it really is about that full cycle, the contrast.
Precisely. Your brain chemistry seems to depend on it. And this isn't just an adult problem. The adolescent data is concerning too.
Right, the study looking at outdoor ALAN exposure for teenagers.
Yeah, it showed that kids exposed to more artificial light at night went to bed progressively later, slept less, sometimes up to 11 minutes less per night in the highest exposure areas.
And that tied into mental health risks for them too.
Directly. Increased odds of mood and anxiety disorders. And it's not just at home. Think about institutional settings.
Like hospitals.
Exactly. One study looked at pediatric patients, kids getting stem cell transplants. They often spent half their time in light conditions that were just wrong. Too dim during the day, maybe too bright at night. Many hospital rooms just don't hit those daytime light levels needed to keep the circadian rhythm healthy.
That's sobering. Okay, let's shift to pillar 2. Consolidating calories or meal timing. We obsess over what we eat, but you're saying when is just as important.
Maybe even more so for circadian alignment.
Mm-hmm.
See, it's not just your brain that has a clock. Your organs do too.
Your liver has a clock?
Pretty much. Your liver, your pancreas, they have their own internal timing. And the liver at 10 in the morning is doing very different things than the liver at 10 at night. Your body is biologically optimized to handle calories late morning to early afternoon.
So eating late really messes things up internally.
It does. It forces those organs, like your liver and pancreas, to basically work overtime when their clocks are saying time to shut down, repair. Insulin sensitivity, for example, is naturally lower in the evening.
So it's less efficient.
Right. And eating late can disrupt your body clock timing. It raises your core body temperature when it should be dropping to help you sleep. And digestive processes might not get fully completed.
Okay, that's a clear mechanism. So what's the practical advice? The rule? Can I have a tiny snack before bed?
For optimal alignment, the science is pretty clear. Finish your last caloric intake at least 3 hours before your intended bedtime.
3 hours. That includes drinks, too, like juice.
Yep. No caloric drinks, no snacks. Water is fine, but nothing with calories. You need that window for digestion to wind down before sleep.
And food quality still matters.
Oh, definitely. High sugar, high saturated fat diets are known to fragment sleep, make it less restful. On the flip side, things like walnuts actually contain compounds that can boost your natural melatonin.
Interesting. Okay, 3-hour rule. Tough, but makes sense. Pillar 3, consistency. Seems obvious, sleep consistently. But how critical is it really compared to just getting, say, 8 hours total?
It's fundamentally critical. It's the anchor. There was this one study, quite compelling, that found sleep schedule instability. So big swings in your wake-up time day to day is a better predictor of mortality than just total sleep duration alone.
Wow, better than total hours.
Yeah. Your body thrives on predictability and needs to know when morning is coming. You really can't catch up on sleep effectively over the weekend, biologically speaking.
That's the social jet lag idea, right? The difference between your weekday alarm and your weekend lie-in.
Exactly that.
Yeah.
That difference creates internal turbulence. And there's no clearer example of society forcing this kind of misalignment than early classes for university students.
Right, the big university study. Over 23,000 students tracking their Wi-Fi logins for attendance. What did it reveal about 8 a.m.s?
It was pretty stark. Wi-Fi confirmed attendance was roughly 10 percentage points lower for those 8.0 a.m. classes compared to classes starting at 10:0 a.m. or later.
And they weren't just ditching class.
Not entirely. The actigraphy data that's like wearing a sleep tracker showed they often just slept right through the start. They missed almost a third of their 8.0 a.m. classes simply because they woke up too late.
And crucially, linking back to consistency, they didn't adjust their bedtimes.
No, not significantly. They just forced themselves awake about 1.7 hours earlier than their bodies wanted to on those early class days. The result, over an hour less sleep compared to days without an 8.0 a.m. start.
And this had academic consequences.
Absolutely. Stacked up. Students who had more morning classes scattered through their week had progressively lower GPAs, the highest grades. Those went to students who had no morning classes at all.
That's a powerful case for later start times, matching biology.
It really is. It shows the tangible cost of ignoring these rhythms.
Okay, let's pivot slightly. The midday nap, good or bad? Helpful recharge or sign of a problem? The data seems a bit mixed.
It's definitely complex and seems very dependent on age. There was a large study, over 3,000 people, looking specifically at naps and the risk of cardiovascular disease, heart attack, stroke, heart failure.
And the overall finding?
Generally, more frequent naps or longer naps were linked to a higher risk of these CVD events across the board. The sweet spot, the lowest risk, was associated with napping maybe once a week or really hardly at all.
But hang on, if you've had a terrible night, isn't a short nap still better than being dangerously drowsy? Is the study saying just push through?
That's the paradox, exactly.
Yeah.
Many researchers suspect that excessive napping, especially long or frequent naps, might often be a symptom of poor nighttime sleep quality rather than the direct cause of the health problems.
So the nap is flagging an underlying issue?
Potentially, yes. But the study did pinpoint a group where the association was particularly strong. It was most pronounced in the 65 to 74 age group.
Okay, specific age range.
And even more specific, within that group, the link was strongest for females.
Really? Females aged 65 to 74, how much did the risk go up?
For those women, yeah, the risk of CVD events and even death went up significantly if they napped more than 5 times a week,
Mhm.
or their naps regularly lasted longer than about 50 minutes.
That's quite specific.
It is. The exact reasons why maybe it affects the nervous system or stress hormones, we don't fully know. But it suggests that if you're in that demographic and napping a lot, it's probably worth talking to your doctor about your nighttime sleep. Interestingly, they didn't find this strong link in people 75 and older.
Fascinating nuance. Okay, let's wrap up with a look at actually treating sleep problems, specifically postpartum insomnia, a really tough time for new parents.
Absolutely. Infant care is a major sleep disruptor. To understand how chronic insomnia develops here, there's a useful framework called the 3P model.
The 3P.
Yeah. Predisposing factors like your individual vulnerability to sleep issues. Precipitating factors, the trigger, like the baby waking you up. And, crucially, perpetuating factors.
Perpetuating, meaning what keeps it going.
Exactly. The unhelpful thoughts, anxieties, and behaviors about sleep that develop because of the disruption. I'll never sleep again, I need 8 hours, or I can't function, spending too much time awake in bed, that kind of thing.
Okay, so a trial looked at interventions targeting different Ps.
Right. A randomized controlled trial with 127 first-time parents. They compared 2 active interventions against a standard sleep hygiene advice group.
What were the interventions?
One was a responsive bassinet. Think of it as targeting the precipitating factor, the infant waking. The bassinet was designed to automatically soothe the baby to reduce parental wake-ups.
Okay, tackling the trigger.
The other was cognitive behavioral therapy for insomnia, CBT-I. This one targets the perpetuating factors, those unhelpful thoughts and behaviors around sleep.
And the results. Which one actually prevented postpartum insomnia long-term?
The results were very clear. CBT-I worked. It significantly reduced insomnia symptoms over the first year, pushing parents into what's considered the absence of insomnia range, a solid medium effect size.
And the fancy bassinet.
Despite being liked by the parents, the responsive bassinet did not prevent postpartum insomnia.
Wow. So fixing the trigger wasn't enough.
It seems not. The key takeaway is this. To head off chronic insomnia, especially in a situation like new parenthood, you really have to address those maladaptive thoughts and behaviors, the perpetuating factors. Just reducing the initial disruption isn't sufficient on its own to stop the cycle.
That really underlines how much our reaction to sleep disruption matters.
It does. It brings it back to the idea that chronic sleep health isn't just about the external chaos, but also, maybe even more so, about our psychological and behavioral response to that chaos.
So we've covered a lot of ground. We've swapped the noise for the science, the power of light contrast, that strict 3-hour rule before bed for meals, the very specific risks of napping for women aged 65, 74.
And the effectiveness of CBT-I in tackling the mental side of insomnia, not just the trigger.
Right. What really strikes me is just how deeply our modern world, the city lights, the school schedules, even our eating patterns, seems built to knock our biological clocks out of whack.
It's a profound mismatch between our ancient biology and our modern environment.
Which leaves us with a final thought for you, the listener. Given that the science clearly shows these external factors building lights, class times are powerfully shaping our internal biology. Should we view fixing sleep only as a personal quest? You know, buying the right glasses, the perfect mattress.
Or does achieving true population-level circadian health demand something bigger?
Right.
Does it require broader societal shifts in how we structure things? Thinking about school start times, workplace flexibility, maybe even regulations around things like hospital lighting. Where does the real responsibility lie?
And that's a wrap on this episode of MedDecode. I really appreciate you joining me today. If something we talked about sparked your interest, or if there's a medical term that's been bugging you, let me know in the comments. And if you enjoyed this, be a pal and share it with a friend. We'll catch you on the next one.